when I did the forecast, I ended up moving average and then exponential smoothing for the 8 period, right? For the moving average, the result was 60, 61, and 54.8, right? Let's say even 55. So I need to decide which of these forecasting methods is the best one, and for that I need to use the forecast accuracy, right? Or forecast error, the more correct terminology is. I can use multiple metrics. The one I prefer are two. One of them is called mean absolute deviation, and MAD is calculated as I1 to N AI, this is absolute value, sorry, AI minus FI divided by N. Now N is the number of pairs or observation that you have the actual and forecast value, right? In our case, when we used the moving average, weighted moving average, and exponential smoothing, we started from F4, and we have an A4, we did A5, F5, F6, F7, and F8, but for F8 we don't have an actual value, so our pairs are time period 4, 5, 6, 7. That means in our case N is 4. Right? So now we need to do the calculation. I'm gonna say MAD moving average, and that is basically the first month was 40, the first time period we forecasted, which was F4, actual 40 and forecast was 40. The second one was 60 minus 43.3 plus 50 minus 50 plus 70 minus 50, right? And then I have 1, 2, 3, 4, so that means I'm gonna divide by 4, and I will end up with 9.175. Okay, so that is my mean absolute error. When I forecast a number, on average I am 9.175 away from the actual number, right? Then I can do the mean absolute deviation weighted moving average, and that is basically 40 minus 41 plus 60 minus 43 plus 50 minus 51 plus 70 minus 50, right? And again I'm gonna divide by 4. That will give me 9.75. And finally, if I do the MAD exponential smoothing and do the all calculation again, I will end up with 11.275. Right? So basically, according to these numbers, the smallest is the moving average. That means moving average best fits this data, and we should use moving average to forecast the demand. Consequently, our forecast for the next month is this one, 60. Another forecast accuracy metric or forecast error metric is called standard error of forecast. Okay. Or SF, and its formula is as follows. Again, we are using the same idea, ai minus fi, but this time we get this, we take the square of that number, divide by n minus 1, and then finally square root of entire number. And so I can go calculate the SF values, and I'll show you one and then give the result for the others. The SF value is for moving average 40 minus 40 squared plus 60 minus 43.3 squared plus 50 minus 50 squared plus 70 minus 50 squared, and divided by 4 minus 1. The result is 15.04. Right? If I do the SF value for weighted moving average, the result is going to be 15.18, and SF value for exponential smoothing is that 16.40. Right. Once again, it seems weighted moving average is the best technique, and we should go with the forecast of 60. So once I choose this forecasting method, I should use this one at least for 6 to 12 time period, depending on how long the time periods are. And then, you know, if you are talking about weekly, monthly demands, perhaps every year I can go and reevaluate the forecasting techniques and choose the next best one. It could be the same one or it might change.